Hello, my name is Deborah Evideno and my matrix is 07DTP20F1013. So I will be presenting about the fundamental of cutting operation. Firstly, plain blanking. The plain blanking operation consists of a punch going through the material. During the working strokes on the written strokes, the material is lifted with the punch and is removed by the strip plate. Secondly, piercing. Piercing is the operation consists of simple hole punching. Punching is the scraps and the strip is the workpiece. Third, lancing. A hole is partially cut and then one side is bent down to the form. A sort of tap all over. No metal removal, no scrap. It is a special form of piercing operation in which the entire contour is not cut. The blank material remains attached with the sheet. It is achieved by bending down one of the side partial punch hole. And then cutting off and parting. Parting or cut off is operation of cutting a piece off by slicing a groove all the way through it with a special parting or cut off tool. Notching. Notching is a metal cutting process used on metal sheet or thin bar stock, sometimes on angle section or tube. A shearing or punching process is used in a press so as to cut vertically down and perpendicular to the surface, working from the edge of a workpiece. Shaving. Shaving is secondary operations usually following punching, in which the surface of the previously cut edge is finished smoothly to accurate dimensions. Trimming. Cutting unwanted excess material from the periphery of previously permanent component. And the cutting action in punch and die operation. The punch contacts the workpiece materials supported by the dies and a pressure build-up occurs. When the elastic limits of the work material is exceeding, the materials begins to flow plastically. The punch penetrates the work materials and the blank is displaced into the die opening. A corresponding amounts, a radius is formed on the edge of the hole and the bottom edge of the blank according to the figure. Compression of the slug materials against the walls of the die opening burnishes a portion of the edge of the blank according to the figure. At the same time, the plastic flow pulls the material around the punch, causing a corresponding burnish area in the work material. Further, continuation of the punching pressure then start fracture at the cutting edge of the punch and die. Under the ideal cutting conditions, the fracture will meet and the remaining portion of the slug edge will be broken away. A slight tensile bar will be formed along the top edge of the slug and the bottom edge of the material. Relation between die clearance with the cutting action in punch and die operation. The clearance between each side of the punch and the die is normally expressed as the percentage of the material thickness. The clearance provided between the punch and die depends largely upon the mechanical properties of the metal to be sheared and the operation being performed. Types of die in the manufacturing process. Blanking dies. Blanking is a steel manufacturing process in which flat geometric shapes is created by the feeding coil of the sheet metals into a press and die. In this process, blank is punched out from the large metal sheet. Secondly, perching dies. The perching operation is used to pierce holes in stamping. Bending dies. The bend die is a tool, a mold which allows tubes to be bent around it and define the result shape of the bent tube. The bent dies are the most commonly bolted. It is also possible to fix it directly to the machine using the flanks. The die is usually fixed using a key. Forming dies. Forming dies are used for metal press forming productions after mounting into a press. The die is a metal block used to form materials like sheet metals and plastic. For vacuum forming of plastic sheets, a single form is used. Drawing dies. Drawing dies are typically made of two steels, tungsten carbide or diamond, with tungsten carbide and manufactured diamond being the most common. For drawing very fine wire, a single crystal diamond die is used. Progressive dies. Progressive die stamping is a process used during metal forming that can create parts of the horse industry. Progressive dies are often utilized in higher volume production with their components engineered to function at the higher rates of speed. Compound dies. Compound dies produce a complete blank in one station at every stroke of the press. Basically, these dies perform one or more operations at the same time. For instance, they can blank, cut the outer form, and the pierce cut the inner form of a shape. Combination dies. Combination dies are used in workstation to handle a combination of process. In these dies, the cutting of metal sheet is combined with other actions such as drawing or bending. So, as the same suggests, combination dies are designed to handle a combination of tasks or process on the workstations. Complete die designing. Die block. Die block is a female part of the tool. It is used to cut or form the stock material with the conjunction of male part, which is called punch. Cutting dies give the required shape of opening or blanking and perching holes. The shape of the dies are replica of the required shape. Punch and punch plate. Punch plates, also known as punch plates and additionally perforated metal, is a sheet metal that has been stamped or punched to create a pattern of all slots or decorative shapes. Pilot stripper and pressure pad. A stripper plate, commonly known as bridge stripper, is simply a plate mounted on the lower half of the tool that strip or pull the metal from the cutting punch. A pressure pad is pressure-loaded plate, either contoured or flat, that holds strips and controls the metal. This is the first mechanism involved in die operation. And then blank size. And bending methods. There are 7 typical methods of bending in the industry. Inductions bending, rotary draw or compression bending, roll bending, plate rolling, point bending or gag pressing, synchronized incremental bending, and hot bending, which is used to induction or other heating sources. Bending allowance and bending pressure. Bending is a manufacturing process that produces a V shapes or U shapes or channel shapes along a straight axis in ductile materials. Most commonly, sheet metal. Commonly used equipment include box and pan brake presses, and other specialized machine press. Typically, products that are made like this are boxes such as electrical enclosure and rectangular ductwork. Percent reduction, depth of draw, drawing force. Calculate the required force to deep draw a piece of sheet metal based on the drawing ratio, sheet thickness, and the ultimate tensile strength of the materials. The drawing ratio is a measure of severity of the drawing operation and is the ratio of the initial blank diameter to the punch diameter for a given material. The limiting drawing ratio LDR is a measure of the material deep drawability and is calculated from the largest blank that can be completely deep drawn from a given punch diameter. And then this is the design of a blanking part. A blanking dice of the blanking part shows the structure of a standard blanking die. This is a die that fixed stripper structure. The blanking die is divided into a top die, which is constructed from shank, a punch holder, a punch plate, and a punch, and a bottom die, which is constructed from stripper, a die, and a die holder. This is a detailed drawing of the blanking dies. The assembly of the blanking dies is also made of the hardware-resistant metal. Is finished ground to predetermined size and tolerance in size. It is made as small as possible, consists with the required strength. It is a good fit and is nicely bended into which accommodates in its order to avoid the heavy stresses and also to eliminate slackness developing the shock of condition of service. This is the example of the forming 3D design of blanking dies. Is an exploded drawing of blanking dies. The center point of the ring lorem move around the axis of a stationary workpiece in a plane spiral locus like a rounding hula hoop. Thereby, the rim of stationary workpiece is rolled and thickened. For the sustainable element to increase the tool life and awareness of environment, firstly optimize your depth of cut, which although the DOC could never exceed the 1/2 of the insert in script circle, determining the ideal depth of cut. For turning application mostly depends on how much the material can be removed per pass without dragging the item out of the chuck. Secondly, consider flank wear in the fit rate formula. In this country, especially Malaysia, milling operator utilize inch per minute (IPM), which is equal to the chip load per tooth multiplied by the number of teeth, while the lathe operator measure fit rates in inch per revolution, which is IPR. The best wear to have is on the flanks. Therefore, it is good idea to fit above the manufacturer suggests range, that presuming your machine tool is strong enough to handle it and you have a good holds, and of course